Hey everybody, this is Greenwood again with another tutorial. Today I will be making some tutorials about MATHia to hopefully help you get through these workspaces with a little guidance if I'm not available to help you. So this is a workspace called Calculating Distances on the Coordinate Plane. It is Unit 4, Workspace 1, I believe. And so let's get right into it. Let me reset that so we know what we're looking for. So it's really helpful if you read through the stuff at the left-hand side. I will not, but it would be helpful if you do that to help make sense. So what we're doing is we're looking at the coordinate grid, and we're trying to find the length of segment AB, and we're going to use right triangles to do that. So think Pythagorean theorem is kind of going to be our focus here. So the left pane always has some work. The right pane always has where you enter your answers. So if I look at enter the coordinates of point A as an XY pair, if I go along the x-axis, I have to go over 1 unit to get to where A is, and then up 2 units for the y. So this will be 1, 2. All right, right 1 and up 2. To get to B, I can kind of follow my cursor down to 11. So I go X, I go 11 in the X direction, and then I go up 8 in the Y direction. Yeah, so 11, 8. Make sure you put these in parentheses because they are coordinates or ordered pairs, and it will mark you wrong if you don't do that. Okay, so when you do these problems, A and B kind of work the same every time. Point C will too, but you actually have to move point C here. So you can drag it around, and we want to make a right triangle so we can do A squared plus B squared equals C squared. So there's lots of places you can get this box for the right angle, but we want to make sure we have one that's on where these gray lines cross, so the grid lines. So the easiest thing to do is to make that right triangle right there. The other place you could put it that would be pretty easy would be up here, like that. Either one works, but I'm going to go down here for this one. So coordinates of point C, so I know C right here. So from 0, 0, I'm going to go over to 11 and then up 2 units. So you can follow the scale or you can count them over. So that's at 11 and up 2. Okay, so I'll scroll so my face isn't in the way there. So determine the length of the longer leg. So now's where we're going to get into our Pythagorean theorem. So the longer leg looks like AC to me. It looks like this leg is longer than that one. And remember, this is the hypotenuse. So AC and BC are the two legs. So which one's longer? So from A to C, from B to C, it looks like this one. So from A to C, I'm going horizontal. So I can just subtract my x values. My x value at C is 11. My x value at A is 1. So I can just type in 11 minus 1. And it's 10 inches or 10 units. So I can also count. There's 1, 2, 3, and I'm counting by gray lines, 4, 5, 6, 7, 8, 9, 10. Sure enough, it is 10. All right. So let's do this for BC also. So from here I count up, that's 1, 2, 3, 4, 5, and 6. And my Y's are 8 and 2, so 8 minus 2 indeed verifies that our counting was correct and it's 6. Okay, now move my face up there real quick. We need to find the length of AB using Pythagorean theorem. Think A squared plus B squared equals C squared. So I've got a handy place we can do that. So right over here, you'll see I've copied that picture. We already determined that this side was 10, this side was 6, and this side is X that we want to know. Okay, so remember our right angle across from that's the 90. There's my C, and then my B, and my A. So we're going to do A squared plus B squared equals C squared. All right, so we're going to do 6 squared plus, let's see, we'll do light blue here for color, 10 squared, and that's going to equal X squared. All right, remember squared means times itself, so 6 squared is 36, plus 10 squared, that's 100, and that equals my X squared. And don't forget to add together the 36 and the 100 to get 136. And that equals my X squared. And then lastly, remember the inverse or opposite of squaring something is to square root. So I'm going to take the square root of 136 in my calculator here in just a second. and we'll get our answer. So x equals, I got to go pop my calculator open over here. Give me just a second. And you can use that decimal scientific calculator is great, or you can use your phone, whichever you like better. So in my scientific calculator, I got 11.6619. I always like to go one decimal place, or three decimal places. MATHia likes 4 for some reason. So that means the length of this segment AB is 11.6619. So if we go back over here, 11.6619, hit enter, we get the check mark, we're good to go. All right, so the rest of these problems in this workspace work almost exactly the same. They will ask you a context question like this one, how many inches? It's going to be just the same answer as what you calculated here. So how many inches from A to B? 11.6619. It might ask you how many blocks or something. But key points, make sure you do coordinates for A and B. X first, Y second. So go left and right first, up and down second for your coordinates. Remember to put them in parentheses. For point C, remember to make the right angle and have the point for C be on the gray grid lines so you can easily count where that point is. To find the lengths, you can subtract the X's and subtract the Y's for whichever one is longer and shorter, or you can count the boxes, whatever works best. And then Pythagorean theorem, a squared plus b squared equals c squared to find the length of your segment. All right, that's all there is for this one, and we'll see you in the next video. Bye.